Hey guys, in this video we will be going over how to simplify, multiply, and divide rational expressions. So let's begin with defining what a rational expression is. A rational expression is an expression that can be written in the form p over q, where p and q are polynomials, and of course, q is not equal to 0. So the following are all examples of rational expressions. And it's important to understand the following facts about rational expressions. So a fraction or a rational expression equals 0 when the numerator equals 0, since 0 divided by a number equals 0. And a fraction or a rational expression is undefined when the denominator equals 0, since we can never divide by 0. We can also write rational expressions as an equation in function notation. So let's refresh our knowledge by talking about the domain of a rational function. The domain of a rational function consists of all real numbers except the value or values of the variable that make the denominator equal 0. Again, because we can never divide by 0. Therefore, to determine the domain of any rational function, we set the denominator equal to 0 and solve for the variable. The value that makes the denominator equal to 0 is not in the domain of the function. So for this example, 8 would not be in the domain. So let's try an example. For this function, we want to find f of 6. And to find this, we substitute 6 in for x. Simplifying this, we get 36 minus 9 over 13. Which is 27 over 13. Therefore, f of 6 is equal to 27 over 13. For part B, this time we need to find the x value that will make the entire function equal 0. And remember, in order for a rational expression to equal 0, we only need the numerator to equal 0. So we just take the numerator and set it equal to 0 and solve for x. We have a quadratic equation here, so to solve this, we need to factor the left side, which is a difference of 2 squares. So it factors to x plus 3 times x minus 3. And then we can use the zero factor property to solve this. We get two answers, x is negative 3 and x is 3. Therefore, our function equals 0 when x is negative 3 or x equals 3. For part C, the domain for a rational function will be all real numbers except the value that will make the denominator equal 0. Therefore, we set the denominator equal to 0 and solve for x. We get x equals negative 7, and this value will not be in our domain since negative 7 will make the denominator equal 0 if we substitute it in for x. So our domain for this function is all real numbers except when x is equal to negative 7. And we can write the domain in interval notation in the following way. Okay, let's do another example where we need to determine the domain for a rational function. Again, the domain for a rational function will be all real numbers except the value or values that will make the denominator equal 0. So we will set the denominator equal to 0 and find those undefined values. Since this is a quadratic equation, to solve this, we have to factor the left side. This will factor to x plus 4 times x minus 1. And using the zero factor property, we can set both factors equal to 0 and solve for x. So our undefined values of x are negative 4 and 1. Therefore, our domain will be all real numbers except x equals negative 4 or x equals 1. And our interval notation will be the following. So it might help to draw a number line for the domain. We would have open circles at negative 4 and 1 since we can't include these values, and we shade everything else. Okay, for the next function, the domain will be all real numbers except the value or values that will make the denominator equal 0. However, since there is no variable in the denominator and we only have a constant, the denominator will never equal 0. Therefore, our domain will just be all real numbers and in interval notation, negative infinity up to positive infinity. Okay, now let's go over how to simplify rational expressions. Let's start simple. To simplify a rational expression like 8 over 12, we would normally have to divide out the greatest common factor between the numerator and the denominator. 8 and 12 have a GCF of 4. Let's do this by writing 8 as 4 times 2 and writing 12 as 4 times 3, where we write the numerator and denominator as factors. And now we can divide out this common factor of 4. This reduces to 2 over 3. This approach is very similar to how we will simplify more complicated rational expressions. So the procedure for simplifying a rational expression is to completely factor the numerator and denominator, and then to divide out the common factor between the numerator and denominator. So say P, Q, and C are polynomials, then P times C over Q times C is equal to P over Q, where Q and C are not equal to 0. So here P times C and Q times C are written as factors, and we can divide out the common factor C. So let's try some examples. We want to simplify the following rational expression. So we can simplify this by reducing 20 and 5, since they have a GCF of 5, and this reduces to 4 over 1. And we can reduce the x to the 6th over x to the 4th by using the quotient rule of exponents and subtracting the exponents. There are more x's on top, so x to the 2nd remains in the numerator. Therefore, this expression simplifies to 4x squared. For the next example, to simplify this, we need to factor both the numerator and the denominator first. The numerator has a GCF of 4, so we can factor this out. And the denominator has a GCF of 7, so we can also factor this out. Now that both our numerator and denominator are completely factored, we check to see if there's any common factors that we can divide out. We can divide out the common factor of x plus 3. Therefore, this expression simplifies to 4 over 7. To simplify this expression, again, we need to factor both the numerator and the denominator first. The numerator has a GCF of 3, so we can factor this out. We can actually still factor this, since this is a difference of 2 squares. So this factors to x plus 1 times x minus 1. And our denominator can factor to x plus 8 times x plus 1. Now that we have both our numerator and denominator completely factored, we check to see if there are any common factors that we can divide out. We can divide out the common factor of x plus 1. Therefore, this expression simplifies to 3 times x plus 1 over x plus 8. So we need to be careful. Notice that we divide by factors and not terms. For this expression, we can divide by the factor x plus 5. However, for the second expression, we cannot divide by x, since the x in the denominator is a term in a sum, so this would be incorrect to do so. So sometimes we will have to rewrite a rational expression in order to simplify by dividing out a common factor. What if we have a rational expression like x minus 4 over 4 minus x? We cannot divide this factor with this factor, since they are not exactly the same. We can start with rearranging 4 minus x as negative x plus 4. Here the x is positive, and the x here is negative. The same with the 4, it's negative here, but positive here. We can actually use a trick where we factor out a negative 1 from the denominator. Doing so, we get x minus 4 over negative 1 times x minus 4. Now these factors are the same, and we can divide them out. So this will simplify to negative 1. This trick is handy if we see that factors almost look the same, but are just opposites. So let's go over some examples where we have to use this trick. Again, we would need to factor both the numerator and denominator. The numerator is a difference of two squares, so this would factor to 5x plus 3 times 5x minus 3. We can't factor the denominator, but it may be helpful to rearrange the terms as negative 5x plus 3. And right now, we do not have common factors that we can divide out from the numerator and denominator. However, if we factor out a negative 1 from the denominator, then now we have a common factor, and we can divide this out, and we are left with 5x plus 3 over negative 1, which is the same as negative 5x minus 3. Now let's go over how to multiply rational expressions. With a simple example, if we multiply 3 over 5 times 10 over 11, one way to multiply this is to multiply the numerator straight across and the denominator straight across. So 30 over 55, and then simplify. 30 and 55 have a GCF of 5, so dividing out 5, this reduces to 6 over 11. But a better way to do this is to simplify first, and then to multiply across. So notice that we can simplify 10 and 5 here, since they have a GCF of 5. Let's rewrite 10 as factors as 5 times 2. We can now divide out the common factor of 5 from the numerator and the denominator, and now multiply across, which also gives us 6 over 11. Simplifying first is useful because then we don't have to worry about simplifying our final answer. This same strategy can be applied to multiplying more complicated rational expressions. So the procedure to multiplying rational expressions is to factor both the numerator and the denominator, and to simplify by dividing out common factors and then multiply across. So for this example, we want to multiply the rational expressions. So first, let's simplify. 12 and 6 have a GCF of 6, so we can rewrite 12 as 6 times 2. And then x to the 4th and x to the 9 have a GCF of x to the 4th, so we can rewrite x to the 9 as x to the 4th times x to the 5th. And then y to the 5th and y squared have a GCF of y squared, so we can rewrite this as y squared times y to the 3rd. And now we can divide out the common factors. Then multiplying across, this reduces to 2 times y cubed over x to the 5th. If we wanted to, we could have also just simplified from the beginning in the following way, since these terms are already written as factors. For the next example, we will need to factor this numerator and this denominator. So for this expression, these terms have a GCF of 8 that can be factored out. So we can rewrite this as 8 times x plus 6. And then for this expression, we have a difference of two squares here. So this would factor to x plus 6 times x minus 6. And then for these terms, we can just leave it as is, or if you want, we can rewrite x to the 6 as x squared times x to the 4th, so that we can easily see what factors can be reduced. Now we can divide out common factors. X plus 6 divides out, and so does the x squared. And we can also reduce 8 and 10 since they have a common factor of 2. And multiplying across, this gives us 4 over 5 times x to the 4th times x minus 6. For the next example, it looks like all numerators and denominators can be factored. Let's start by factoring this numerator. We can factor this by using the factor by grouping method and finding two numbers that multiply to negative 4 times 3, which is negative 12, and add to negative 11. Those numbers are negative 12 and positive 1. So we write this trinomial as 3x squared minus 12x plus 1x minus 4. And then factor by grouping. Factor out the GCF from both groups, and then factor out the common binomial x minus 4. And this will factor to x minus 4 times 3x plus 1. To factor this denominator, we can use the shortcut approach, and this will factor to x plus 5 times x minus 4. To factor this numerator, we can also use the shortcut approach. This will factor to x plus 5 times x plus 5. And then finally, for this denominator, we can factor out a GCF of x. And now that all the numerators and denominators are completely factored, we can divide out common factors. And then we are left with x plus 5 over x. Now let's go over how to divide rational expressions. Again, let's start with the simpler example. So 7 over 4 divided by 3 over 8. To divide these two rational expressions, we would multiply by the reciprocal, using keep, change, flip. So this expression can be written as 7 over 4 times 8 over 3. And now we would multiply as normal. Again, it's useful to simplify and then multiply, so 8 and 4 have a GCF of 4 that can be divided out. And once we divide out the common factor, then we can multiply across, which is 14 over 3. This same strategy can be applied to dividing more complicated rational expressions. So the procedure to dividing rational expressions is to multiply the first rational expression by the reciprocal of the second rational expression. So if we have p over q divided by r over t, where p over q and r over t are just rational expressions, with q, r, and t not equal to 0, then we can rewrite this as p over q times t over r. Okay, let's try some examples. We want to divide the following rational expressions. First, we will need to rewrite as multiplication by multiplying the first rational expression by the reciprocal of the second rational expression. So we keep the first expression the same, change the division to multiplication, and flip the second expression to its reciprocal. Now that we have it written as multiplication, we can start simplifying. 36 and 4 have a GCF of 4, so we can rewrite these as factors with that GCF. X to the 5th and x squared have a GCF of x squared, so we can also rewrite these as factors with that GCF. And then y to the 4th and y to the 10th have a GCF of y to the 4th, so we can also rewrite these as factors with that GCF. Now we can easily divide out the common factors, and then multiplying across, we get 9x cubed times y to the 6th over 1, which is just 9x cubed y to the 6th. For the next example, again, we need to rewrite as multiplication by multiplying the first rational expression by the reciprocal of the second rational expression. So keep the first expression the same, change the division to multiplication, and flip the second expression to its reciprocal. Now we have it written as multiplication, and we can start simplifying. So to simplify, we will need to factor every numerator and denominator. So this numerator factors to x plus 4 times x plus 4. Then this denominator factors to x minus 8 times x minus 3. And then for this numerator, let's first write it in descending order of powers as negative 5x plus 15. And now we can factor out the GCF, which can either be 5 or negative 5. But let's factor out a negative 5, because looking ahead, we'll then be able to divide out a common factor of x minus 3. And then finally, this denominator factors to x plus 4 times x plus 1. Now that we have completely factored all numerators and denominators, we can divide out the common factors. Multiplying across, we have negative 5 times x plus 4 over x minus 8 times x plus 1. And we can leave this written as factors.